This video will be about the economic effect of climate. And most of you are in economics, a few of you are not. So let's review it very, very, very quickly. Basically, economics is that study of allocation of scarce resources. And there's a bunch of words in here that are in bold that I kind of want you to know. So this is a very classic diagram of supply and demand, where generally the idea is that the more something costs, say along this line, if it has a very high price, there'll be less of it made. If something is very cheap, there'll be more of it. There are, of course, exceptions to this. And basically the idea is that how much something is needed drives how much it is produced. And that becomes important later on. The point at which you sort of have your supply and demand meet is your market price. And this is going to be important. We're going to be talking about market price, especially as it relates to carbon, for the next bit of this video. So there's a bunch of definitions on here. So one of the problems is that when you're talking about things from tires to Beanie Babies to whatever's being sold in a store, its market price is sort of assigned by the market. When we're talking about environmental pricing, we're trying to assign a value to things that you don't go out and buy. So, for example, you don't go out and buy clean air. I guess you go out and you buy water, due to bottled water. But we're basically trying to put a number on things which are sort of ambiguous. So market benefit refers to the things that you can buy and sell. I put a list of them up here, but they're those things that you go to the store and you get. The non-market benefit is the economics word. In science, we would call this ecosystem services. These are things that you can't really go out and buy, but they still have value. So if you've been paying attention to the news, you saw how in Flint, Michigan, they're having real issues with their tap water. Having clean tap water is a non-market benefit or an ecosystem service. We need, as living beings, clean water. Biodiversity has its own values. Disease and pests, limiting their spread is of importance to us. So these are all ecosystem services, aka non-market benefits, that have value to us, but that we don't go out and buy. But there becomes a problem when we try to assign these numbers. So some people are like inherently opposed to the idea of assigning a value to something in nature, because then it's seen as a commodity. And sometimes people, tend not to value things as much when you can put a number on it. And especially when people are arguing about what that number is. Additionally, there's an issue with the fact that we're taking something, and this is that tragedy of the commons thing that we talk about with the game, but you're taking something that has a public benefit, like an ecosystem service, and weighing it against a private benefit. So, like, for example, there may be a lot of reason why a company pollutes. It's very financially beneficial to them, and they are spreading out the loss of that clean air amongst everyone out there so that they can see it as cost effective. Let me give you an example. So I like this picture. These 25-ish pictures. These are pollinators. So this is an example of an ecosystem service that has had a number applied to it. The number that was applied was 6 to 12 billion US dollars by the USDA, and this was the cost of all crops that are pollinated by bees. And these are a service that bees give us. Thanks, bees. Not so much because they like us, but because they benefit from the spreading around the pollen. But in their action of gathering pollen, they also fertilize plants, right? Little Bio 101 review. But this number has issues. This 6 to 12 billion is literally only the cost it would take if we ran around trying to hand pollinate, or the loss of all that produce to the market. It leaves out all the other services that bees give us as well. For example, they pollinate a bunch of plants that we don't even eat. And does that have value? Well, if you value biodiversity and the ability of an ecosystem to be resilient, it does. So there are a lot of things that we assign a number to that sort of are trying to put hard lines around these abstract ideas. And then this is an example of one. Does that mean we shouldn't do it? In my opinion, absolutely not. We need to be able to value these things in order to make long-term decisions. I mean, it's nice to say we all love nature, but we need to be able to value it so we can make sure it's protected. this picture I like. Everybody's so worried about cow farts, as you may or may not remember. It's the burps that have so much CO2. Here's another term, the negative externality. And this will make sense aside from the definition. But basically, it's the idea that there's this side effect to the public or to the greater group that is due to the actions of an individual or an industry or a corporation or something like that. This is basically the idea of the tragedy of the commons, that somebody is utilizing a resource and we all pay the cost for their utilization of it. So, for example, cows. Cows benefit the dairy farmer. So let's just use a dairy farmer, not the beef farmer, because that's kind of sad. So the dairy farmer raises cows. He feeds them, or she, could be a chick. They feed the cow, and they take up all the costs of feeding and caring for the cows, but they directly benefit from all the money they earn as a dairy farmer. But there's another cost that they aren't paying personally, and that is the cost of the CO2, the greenhouse pollution that the cow is giving off. And that negative externality, that methane and the CO2 that the cow is giving off, is being paid by everyone else, you, me, everybody else. And that's an example of what we're talking about here with this negative externality. And this gets into part of the problem of trying to assign numbers and values to climate change, because almost all of the effects of climate change are these negative externalities, meaning that they're resulting from maybe a small group of individuals, but they're being applied to everyone. So assessing them can be really difficult. And this is not something that's typically found in your traditional economics 101 decision-making class, where it's supply and demand rule everything. They don't take into account limited resources like the ability of the atmosphere to absorb CO2 in perpetuity, thanks, Liam, or the ability of the ocean to absorb CO2 is also limited as well. All right, I'm going to try to say this word, and I hope I say it right. It's Pigouvian tax. Pigouvian tax is based on Pigou, I don't know, who's an economist. And the idea is that if you put a tax on polluting, it can change the behavior of individuals and industry. And additionally, that little bit of money that you take can also be used to mitigate or offset some of the pollution they do. This is sort of like where Superfund came from. There's taxes on oil, as all part of the Clean Water Act. And whenever somebody engages in activity that contributes to, that sort of negative externality that limits our ability to utilize some resource as a group, they pay for it to a small amount, in my opinion. And then that sort of creates this fund that can be used for different things. One of the reasons why this can be really useful is it forces corporations to make polluting part of their economic equation, which is something that should happen. It can remove the tragedy from the commons, so to speak. The IPCC tried to quantify the cost of society as part of those different, it says the annual reports. If you remember those 4 different relative concentration pathways. The U.S. puts a really low value on it, the EPA, which I was surprised by. They say that the social cost of carbon, the SCC, is about $37, and this should say $37 per ton. I apologize. $37, not just like for all the carbon in the world. Let me add a little thing. Per ton. And this includes a wide variety of things that they've decided should be included, and obviously leaves out some things. But they included, because they're the EPA, cost to agriculture. They tried to estimate the cost to human health, though I suspect it's wildly low. The cost for flood damages, for changes in heating and cooling and energy usage, and just about every other thing that they could think of that they thought was quote-unquote significant. But these estimates vary widely. And when I mean widely, you'll see in the next one, it's like as low as, I want to say, I think we have the lowest. I think 37, thanks US, was the lowest. And the highest was like $700+ per ton. And this issue is partly because nobody wants to take into account the future costs. So when the EPA is making their social cost of carbon, they're worried about right now what the immediate effects are. And from playing the game, you guys know that, the carbon kind of lingers. And how much the cost of that carbon will have on future generations is not typically part of an economic model, because the economic model is based on what you have now. And it projects into the future, but it doesn't really take into account the costs. So there's a lot of people who go back and forth about that. Some people actually actively devalue future harm because they think that it will be offset by economic growth. So, I mean, economic growth is something that is sometimes based on this idea of unlimited resources. And hopefully you can see that that's probably not a great idea. And the same thing, others won't value it since it's a benefit to future generations and not this one. This is a graph that was provided us by the people who are really helping us with this lesson plan. But this is kind of the idea. These are a bunch of different models for the social cost of carbon. And you can see at the high end in Sweden, we have this one, Stockholm Environmental Institute. It's interesting because Sweden actually assigns one of the largest carbon prices, which we'll get to in the next one. Here's the USA, way down at the lid. You can see that the USA, the EPA does say that the social cost of carbon will increase over time, which thanks for noticing that, guys. But you can see there's a lot of different issues about this social cost of carbon. Hold on one sec. Okay, so the social cost of carbon is what's called a shadow cost. It's not an actual market price. And it tends to be, the phrase that I had read was called top down. So it looks at all of the things in an area that are going to be affected, but it tends to focus on like big things, industry, infrastructure. They're not really taking into account whether it got Lyme's disease because ticks are around more. So there are things that are going to be missed. And people reassure themselves that their version of the social cost of carbon is the right one to one degree or another. But that's kind of a subjective statement. And those things that are missed still have value, even if they're not as economically valuable as the big things to the companies and to the roads and bridges and whatnot. The social cost of carbon is an important idea, and it's used by governments for making regulations. We're going to talk about the social cost of carbon versus carbon price, which sound very similar in the next video. But already 50 international corporations are also using this idea of social cost of carbon to like make decisions about their economic policy. So this is the beginning of economics, and we'll have another video.